Okay, in this video we're going to be exploring some examples of tangents that involve two segments tangent to a circle. So two tangents, remember, are always going to be congruent when it's from the same exterior point. So we're going to start by putting some markings on the diagram here that AB and AC are going to be congruent, and also in circle Q, our tangents to that circle, AC and AD, are also going to be congruent. So essentially, we can say that this tangent, AB, is the same as AD and set up an equation. So we're going to have negative 2x plus 37 is going to equal 6x plus 5. Moving our negative 2x over, we get 8x. Moving our 5 over, we get 32 after we subtract, and then solving that equation really easily, x equals 4. Next example involving two tangents and circles is not from your textbook, but here's our diagram here. We need to find x still, but notice we have two variables in this picture. So the first thing I need to remember is, again, any two tangents to a circle from the same exterior point are going to be congruent. So I can start by marking DE congruent to DF, and so pretty easily I think you can see that y has to be exactly 10. So once I know that, I can also assume that GD, which is here, this whole entire length, because I'm talking now about tangent to circle T up top, GD is going to be congruent to the other tangent side there, HD. And if that's the case, then if I set those entire lengths together, I need to add up the pieces. So I can say that y minus 5, which is the GE part, plus 10, which is the ED part, has to equal y, which is DF, plus x plus 4, which is FH. And so those two entire lengths of the tangents to circle T are the same. Now remember, we just found y is 10, so let's put that in. And then simplifying, we only have one variable left, so this is 15 equals, simplifying over on the right hand side, we just have x plus 14. So a really quick subtraction, x is 1. Okay, last examples in our video here go with the example 4 from your textbook, and this is talking about a circumscribed triangle. So just want to recall here a little bit about the vocabulary. Remember, anytime we have that prefix circum, that means around. So a triangle has been drawn around the circle, as you can see in the diagram here. So we have triangle ADC that is circumscribed about circle O. What I need to know is that in circumscribed triangles, you guys, the sides, I hope you can see, are tangents. So what that means is when I have this exterior point, let's say we're going to work with exterior point D, the segment DE here and DF are two tangents from the same exterior point D, and so I can go around this circle here and around the triangle, and I can mark some congruent sides. So DE and DF have to be the same, FA and BA have to be the same, and BC and EC have to be the same. Notice I'm not marking them all with the same set of tick marks, but I am setting them equal to each other because they're two tangents from three different exterior points there. So as I start to just kind of put some measures around this triangle, if DF and DE are the same, then that's 6. If AB and AF are the same, then that's 19. And then what we're told in the rest of the problem here is that EC is equal to DE plus AF. So if I write that down, and then substitute in some pieces that I just labeled, EC is our unknown. DE we do know now is 6. And AF we know is 19. So if I add those up, I should get 25. Now, but remember, 25 wasn't what I was asked for. If I go back to what the question is asking for here, is we need to find the perimeter, okay? Perimeter, remember, is adding up all the sides, so that's a pretty easy addition here now that we've found them all. We've got 25 twice, so 25 plus 25 plus 6 twice, if we keep going in clockwise motion around the triangle, and then plus 19 twice. And that's going to equal, if I simplify it a little bit, that's going to equal 50 plus 12 plus 38. And since 12 plus 38 gives me 50 as well, 50 plus 50 gives me 100. So my perimeter is 100, you guys. Okay, on our final example before we get to your yellow on your own pages here, I just have to let you know that the label that you see in front of you in this video I know does not match what's on your paper. I apologize. Please make sure that you write down the correct starting conditions here, which should read that triangle JHK is circumscribed about circle G, and to find the perimeter of triangle JHK if NK is equal to JL plus 29. That should be the initial conditions of this problem. So go ahead and pause it right now and make sure that you wrote down those initial conditions somewhere on your paper, because otherwise you can't solve the problem with quadrilaterals because there's no quadrilaterals on the diagram here. So I apologize, but take a pause and write all that down, okay? Okay, and in this example we can assume with a circumscribed triangle again that we have two tangents at 3 different corners of the triangle that are going to be congruent, so we can put on measures kind of going around the whole deal here. JM and JL have to be the same, so we'll mark JL as 16. LH and HN have to be the same, so HN is 18. And then we don't know what MK or NK is yet, but we'll use the last condition that we were given there, that NK equals JL plus 29, because we now know JL. And so this time NK is going to equal JL is 16 plus 29, or 45. Now remember, that's not the perimeter. We're just going to put 45 onto the diagram at NK and then also at MK, and then add up the pieces that we know. So 45 twice plus 18 twice plus 16 twice. And adding up those pieces, we have 90 plus 18 and 18 is 36. And plus 16 and 16 is 32. So 90 plus 68 gives us a perimeter of 158. So that is it, you guys, for all of our tangent examples. Hopefully you were glad to see those go pretty quickly and just really dealing with Pythagorean theorem and some addition and subtraction, and we're all good. So hope you've enjoyed the circles unit. This is the end of the required videos at this point. Make sure you finish your yellow on your own page, and I'll see you guys tomorrow.